see what confusion matrix is, and then we are going to see some examples. That is the slide that you saw before. We have got a data set that we use to train and test our classifier before we return it back to the user, and the user can use it with unseen data. So we have to give the user some idea of what they can expect from our classifier. If we took all the training data and train a classifier that will perfectly classify the training data or memorize the training data, we don't have a measure of how well this classifier will work with unseen data. This is why we're going to look at a lot of interesting training and testing protocols, which will give us kind of insurance about what we can offer our user, what we can recommend with our classifier. So classifier comes with estimated accuracy. But for now, we are just going to see how we measure classification accuracy. Right? We are going to talk about probabilities, and we are going to talk about probability of error. We want to know what percentage of the data our classifier will get correctly, will label correctly when it is returned back to the user. One way to measure that is through probability of error, which is calculated or estimated actually quite easily. If we have a training data that we set aside and another data that is testing data, which we haven't seen before, or the classifier hasn't seen before, we can estimate the accuracy on that testing data set by counting the number of errors. Well, this is the probability of error, not the accuracy. Number of misclassified objects divided by the number of objects, total number. Just the percentage of the objects classified in the wrong class. So this hat here, P sub E, is for error, and hat means that it is an estimate. This is not the true value of the error because we have got a finite data set with 10 objects, and if n is not very large, if it is not 30 million or however many they have got in ImageNet, we cannot be sure that our estimate is particularly accurate. So the larger the data set, the better. This is always the case. The larger the data set, the more accurate this estimate is. When we talk about probability of error, P sub E, we will be using also the term error rate of the classifier. The error rate of the classifier, and this is what is accepted everywhere. So if you're reading a scientific paper, you will see error rate, error of the classifier. This is what we mean here, error rate and probability of error. And of course, the probability of correct classification is the dual characteristic of the error, which is also called accuracy of the classifier, and it is calculated as 1 minus the probability of error. So I should have put the hats on these two. So these are all estimates. Probability of correct classification equals 1 minus probability of error, and it equals, of course, the number of correctly labeled objects divided by the total, which can also be expressed as 1 minus the other calculation that we had on the previous slide. Simple as that, probability of error and the accuracy of the classifier. Error rate or error of the classifier and accuracy of the classifier. So let's see how we calculate those things in an example. Okay. I like that you're taking notes. This is something that I haven't seen students do for a long time. So I'm really impressed. And taking notes is something that is extremely useful, even though people don't realize that it is extremely useful for learning whatever subject you're learning. Because even if you think that you're just mechanically writing stuff on the paper and You may even not understand what you're writing. It's the very fact that it goes through your eyes, through your brain, and through your hand, and you write it down. It helps your learning tremendously. So if you take a piece of advice from me, please, yes, do take notes. That's a good idea. Okay, so classifier D1, I call it D1, just give it a name, is defined by this discriminant function in a two-dimensional space for this little artificial data set. So how many errors does this classifier commit on the given data set? So I'm not saying how I trained this classifier. Maybe I had a different data set to train it. I'm interested to know the accuracy or the error on that particular data set that is plotted here. There are 40 objects in total. And what is the estimated error? Well, in order to say what that is, we need to know which region is our classifier is taking as the yellow one and which is it takes as the blue one. And of course, makes sense that the yellow is to the left and the blue is to the right. So the errors that the classifier make are those 4 points. And therefore, we are making 4 errors out of 40 objects, and we are calculating the error rate as 4 divided by 40, 0.1. Okay. And here is the confusion matrix. I have put that particular icon over there so that you remember that this is a confusion matrix, but it is not to get you confused. It is to tell us which classes are confused with one another. So the confusion matrix in our examples is going to be square. We can think of a case when we may have a non-square confusion matrix. I will give you a hint later on, but for now, we have got the number of rows and the number of columns the same number, and this is the number of classes. Remember little c? We use little c to denote the number of classes, and we use little omega as the class name. So if we go back to the example of all of us supplying 300 little images of our faces, and our system wants to be trained to recognize person, we are going to have, let's say, 20 classes, because this is how many people we have got in this data set. And the number of elements of the data set, there will be many more, because each of us is going to supply a large number of little images. So in cell with index ij, row I, column j, we have got a number that tells us how many objects from the data set came from class omega I, so their true label was omega I, but our classifier D assigned them to class J. So, for example, how many pictures of me were assigned as one of you? So one of you will be the column and the row will be me, my picture. So ideally, all my pictures should be assigned to me, which means that I want my diagonal element, row I, column I, to be containing all the 300 images that I give to the system. So that would be the ideal case. However, this may not happen, so this is why we are going to have some of my pictures distributed to other people. So my classifier will get them wrong. But all my pictures are that row, true label, Lucy, that row. And they are distributed in these cells, and hopefully most of them are in the diagonal cell, row I, column I. So on the diagonal, we have got correct classification, and everything that is off diagonal is incorrect. This is one true label labeled as another identity. of diagonal elements. Okay, so if we are to create the confusion matrix for this classifier that we saw before, we have C equals 2 classes, therefore our matrix is going to be 2 by 2. We have 2 features which doesn't impact on the confusion matrix in the slightest, it doesn't matter for the confusion matrix. The number of objects, 40 actually, does matter. There are 20 from each class in this example. So we have got 17 yellows labeled as yellows, the diagonal element there in cell 1, and then 3 of the yellows are labeled as blue. So remember, the true labels are in the rows. So the yellow class, all of the yellow class is in the row. 17 labeled as yellow, 3 labeled as blue. The assigned labels, sorry, the second class blue, second row, I have got 1 blue labeled as yellow, and all the others are labeled as blue. So our classifier is pretty good. So we can calculate the errors, the error rate of the classifier, or the error of the classifier, by summing up the off-diagonal elements, because this is where the errors are, and dividing by the total. 4 divided by 40, we get the same answer. But this time we have got the confusion matrix, and we know which objects have been, or how many objects have been misclassified from the 2 classes. This confusion matrix is about this classifier. If we have a different classifier on the very same data set, we will have a different confusion matrix, and probably, and different accuracy or error. They may be the same, the confusion matrix and the error. They may be the same if the classifier doesn't, well, makes a mistake on different 3 objects and from the yellow class and different 1 object from the blue class. You can think of a possibility. It may not be a linear classifier, but I can design a classifier that is a completely different classifier but has the same confusion matrix. So each classifier has got its own confusion matrix on a data set. Here is another classifier, D2, I call it. It is another linear classifier, and you can see the confusion matrix for this classifier. Now I have got 2 yellows labeled as blue, so my first row is 18 and 2, and all the blues are correctly labeled. So this classifier is better on this data set because the error rate is 0.05. How about this classifier? They don't have to be linear classifiers. This is just another classifier, a non-linear one, where the yellow class is in the circle and the blue class is outside. And it has got a larger error rate compared to both the D1 and D2. So the confusion matrix is about a given classifier and how this classifier distributes the objects in the dataset into the classes. Here is an example with 3 classes on the iris dataset that we saw before. So you know that there are 50 objects in each class. There are 150 altogether. And Setosa is the black dot. So looking at this picture, I've drawn a circle around points that are misclassified. And since I've got a 2-dimensional representation of the data, and there are 4 features, some objects fall on top of one another. So this blue and this green, they are represented by the same values, although one is from the blue class and the other is from the green class. And the same happened here and the same happened here. So bearing in mind that you have got 2 objects there, can you tell me what I should put in the confusion matrix? So in this cell here, Setosa true label, Setosa assigned label. What number should I put? $50, that's correct. because all the 50 objects from that class are labeled as that class. And by the same token, what should I put in the second cell, first row, second column? 0. And the other one? 0 again. That's correct. So the versicolor is slightly trickier. So versicolor is the triangle. So how many of the blue triangles are labeled as setosa? What should I put here? 0. Correct. How many blue triangles were labeled as blue triangles? This one, so this one is labeled correctly because I just circled the ones that are wrong. So this one is in the correct region. How many of the blue triangles are labeled as blue triangles? Versicolor as versicolor. That is correct. So what is left for versicolor labeled as Virginica? Yay! They're cooking. How about Virginica? How many Virginica are labeled as setosa? Correct. How many Virginica are labeled as versicolor? 4 of them. And what is left? That's how we fill in the confusion matrix. Well done. Okay, so here is a set of questions to you that you should try to think about. I have got a confusion matrix of a classifier that has got that numbers in it. How many points are there in my dataset Z? So can you, how do you calculate that? How do you know? What do you do? Add them up. Yeah, add them all up, and then you'll have your total number. How many points from Z have class label 2? So the true class label for them is 2. How many of them? 10. Because we know that all the points that have label 2 are in that row, in the second row. 8 plus 2, that will be 10. Next question. Estimate the accuracy of the classifier. So how do we do that? What we can do is sum up the diagonal elements and divide by the total, that will be the accuracy, or sum up the off-diagonal elements, which will be easier to do, and take 1 minus that sum divided by the total. Whichever way, you will get the same answer, estimate of the accuracy of the classifier. Now, that fourth one is a tricky one. If the classifier predicts class label 2, what is the probability that this label is correct? How can you calculate that? So your classifier gives label 2. What are the chances that this label is correct? Okay, so here we are talking about conditional probability. If you remember that from your first year maths, conditional probability means that we are not talking about all the objects in the data set. Our sample space, which we are interested in, is only where our classifier predicts label 2, which means that is the condition, classifier predicts label 2, which means we are looking at this column. Only for these objects our classifier predicts label 2. So out of this, in 8 out of the 11 cases, the classifier has been correct. So the estimate that we are looking for is 8 divided by 11. Okay.